Hello, everybody. My name is Prajwal. I'll be talking about smart city applications using Lora technology. So, coming to the introduction of Lora, according to the forecast by 2050, about 70% of world population will live in cities. Such a huge number of people will require better management of the services offered by municipalities such as electricity, clean drinking water supply, paving and asphalting of streets together with their lighting, separate waste collection, recycling, and construction of new parking lots and garages, etc. One way to improve the quality of the above mentioned services is to use the Internet of Things, that is IoT. Internet of Things involves the connectivity of various small computer systems with low power consumption. The connection method can be wired or wireless. Combining these two ways of connecting to the internet allows for controlling and monitoring and management of different sites that are part of urban infrastructure. So, Internet of Things, it's not mandatory that it's applied only for the smart cities. It can be applied even in the rural areas also for the farming and other purposes. IoT refers to the interconnection of physical devices, vehicles, buildings, and other objects, embedded with electronics, softwares, sensors, and network connectivity which enable them to collect and exchange data. In this way, so called the smart city would be realized. So, coming to the key points about IoT. IoT refers to the interconnection of physical devices, vehicles, buildings, and other objects embedded with electronic software, sensors, and network connectivity, which enable them to collect and exchange data. Now, the key components of IoT are devices, network, data, and analytics. So, when it comes to the devices, these are basically the electronic devices. These can be sensors, actuators, and other smart devices. All these are basically electronic devices. And network, there's a backbone that enables communication between devices. The network can be through GSM module. Currently, IoT supports up to 4G. 5G has not yet been implemented, and you can use wireless, that is Wi-Fi, also as a network. And data, this is the information that is generated and transmitted by devices. So the data will be transferred to the IoT cloud. So whatever cloud has been established. So through that, the data can be accessed. And analytics, this involves the processing and analysis of data to derive insights and inform decision making. So the analytics will be performed on the data that has been collected in the IoT cloud, and based on this, machine learning algorithms or any data mining algorithms can be applied and the data can be analyzed. Now, the examples of IoT applications are smart home, smart cities, industrial IoT, healthcare, agriculture, a lot of other things. So here we're talking about smart homes. Devices like thermostats, lighting systems, security cameras can be connected to a network and controlled remotely. So we have this remote control light monitoring system where you can control or on and off the light and from anywhere, turn on the water heater from a remote location. So this involves smart homes. And when it comes to smart cities, IoT can be used to monitor traffic flow, manage energy consumption, and improve public safety. Industrial IoT can be used in manufacturing to optimize production processes, improve efficiency. Healthcare IoT can be used to monitor patient health remotely and improve healthcare outcomes. IoT can also monitor the heartbeat, SpO2 level of the patients. So, based on that, the data will be sent to the healthcare provider and the notifications will be received automatically. And benefits of IoT are improved efficiency and productivity, cost savings, improved safety and security, enhanced customer experience. IoT is not much costlier to implement than other devices, and it provides efficiency also and safety too. And challenges of IoT, it provides security and privacy concerns for the smart homes. IoT devices can be implemented and through cameras it can be integrated and the data will be stored in the cloud. Interoperability issues, this is also a major problem. And scalability challenges, when it comes to scalability, IoT currently supports for smaller devices like a home or something, but when it comes to bigger cities, the research is still being going on. Data management and analysis complexity. So the data collected will be huge, and analysis of that will be very difficult and takes a lot of time. And the future of IoT is continuous growth and adoption, emergence of new use cases and applications, increasing focus on security and privacy, advancement in AI machine learning to enhance data analysis. Now here as I said, this is smart city using Lora technology. So here we'll be talking about two implementations. One is waste management, and another one is controlling of city lighting. So when it comes to the waste management can be improved through use of LoRa technology, which is low power, long range wireless communication technology. Here are some ways LoRa technology can be used in waste management. Smart city bins, smart waste bins. LoRa technology can be used to create smart waste bins that can communicate with central system to monitor the level of waste in a bin. This helps in optimizing waste collection schedules and reducing the number of unnecessary trips. Tracking and monitoring. LoRa technology can be used to track and monitor waste disposal trucks, making it easier to manage the collection and transportation of waste. The data collected can be used to optimize the routes and reduce fuel consumption. And sensors for recycling. LoRa technology can also be used to monitor recycling efforts. Sensors can be placed on recycling bins to track the type and quantity of materials being recycled. This data can be used to improve recycling efforts, reduce the amount of waste going to landfills, and environmental monitoring. The technology can be used to monitor environmental conditions in and around landfills. Sensors can be used to monitor air quality, temperature, and other environmental factors to ensure that the landfill is operating in compliance with regulations and to ensure the safety of the surrounding areas. Overall, the use of raw technology in waste management can improve efficiency, reduce costs, and help to create a cleaner and more sustainable environment. So, waste produced by urban areas is collected by special trucks owned by companies. The previous points for what we have discussed is being implemented. How it is being implemented is shown here. So, the waste produced by urban areas is collected by special trucks owned by municipality companies or any other private company. The organization responsible for maintaining city cleanliness is unaware of how often trash cans are filled. So, some places or some homes, the trash cans are empty, and some places, the trash cans are overflowing. So, the places where the trash cans are empty, there will be huge traveling time required to see whether the trash can is filled or not. So, this takes a lot of time. And when separate collection trucks arrive, some containers are overflowing and not filled. The LoRa module equipped with Arduino UNO microcontroller system is coupled to ultrasonic sensor and suggested application. So the microcontroller with the ultrasonic sensor will be fixed to the container, that is the waste dustbins. So the container will emit ultrasonic rays and measure the distance. So based on this distance, the companies will know whether the trash can is full or not. And based on that, the company trucks can go to the landfills or places where the dustbin is full and can actually take out the trash. The transmitter produces a wave which, when it encounters an obstacle, part of it returns to a receiving part. Since the speed of sound in different environments is known, the distance of the sensor to the object can be determined based on time interval from the transmission to the reception. The ultrasonic sensor in practical realization can be put on top of the waste bins in type of igloo. The height of the container is 154 centimeter. If it detects that distance between its place and the next obstacle is about 30 centimeter, so it means that the waste level in the basket is about 80%. Then the first message is sent to the LoRa gateway. Information is sent through also to the IoT server. So this information will be received by the company portals, whether they are using IoT cloud or any other service provider. Monitoring of the degree of filling the waste container continues. When it is filled, when the distance is about 5 centimeter, Then a second message is sent to the cleaning company. The sent information from LoRa and module and node through the LoRa gateway has reached the internet. ThingSpeak IoT server is used on system presented here. So this is the truck where it is equipped with GPS, microcontroller, RFID, GSM, and GPRS. So this truck will be receiving the information through GSM technology. So these trash bins have the sensors attached with the RFID. RFID will be used to track where the trash cans are. And these sensors are ultrasonic sensors which will measure the filling of the trash can. So once this filling is done, it will be notified to the trash can bus or truck. So these truck can navigate to the place where the trash can is full and can empty them. Now, the second application is control of the city lighting. By using appropriate sensors and wireless transmission of information based on LoRa technology, the time of switching on and off the city lights could be specified more correctly. This could lead to more economical use of electricity, especially as at its current higher prices. Install LoRa enabled sensors on street lights to detect their on-off status as well as the energy consumption. These sensors can be attached to the lighting control module or can be integrated into the LED light fixture. Connect the sensors to the LoRa gateway, which collects the information from multiple sensors and sends it to the cloud server. The cloud server can then analyze the data and generate alerts when the lights are not working correctly or when they are consuming more energy than expected. This information can be used to optimize the energy consumption of the city lighting system. Use LoRa to remotely control the lighting system. This can be done by sending commands to the lighting control module or to individual lights. For example, turning the lights on or off, adjusting the brightness, or changing the color. Implement a smart lighting system that uses LoRa to adjust lighting based on time of the day, weather condition, or presence of people or vehicles. This can help save energy and reduce light pollution. The data collected can be used to generate reports and dashboards that provide insights into city lighting operations. This can help local authorities to make informed decisions and allocate resources more effectively. So, here on this figure, the LoRa platforms where the street lights have been equipped and the information will be sent to the router. So, the light scheduling will be controlled based on daylight and nighttime. And here, individual light metering. So, individual lighting system will be metered and the prices will be fixed accordingly. So dead lamp alert for maintenance. So if any lamp is not working, it will the alert will be notified and the required action can be taken place. And anti-theft protection. Um, if any intruders will try to take away the lamps, they will be notified also. All this will be controlled by the control room. And the future enhancements: improve data rates, increase capacity, enhance security, improved interoperability, reduced power consumption, integration with other technologies. When it comes to improved data rates, one of the limitations of LoRa technology is its low data rate. Future enhancements could aim to increase the data rate while still maintaining its long range communication capabilities. Increase capacity. LoRa networks are designed to handle large number of devices. However, as the number of IoT devices continue to grow, future enhancements could focus on increasing the capacity of LoRa network to handle even more devices. Enhance security. Security is an important aspect of any communication protocol. Future enhancements of LoRa technology could focus on improving security features to protect against potential cyber threats. Improved interoperability. As IoT devices continue to become more widespread, there is a need for different devices to communicate with each other. Future enhancements could focus on improving interoperability between different devices using LoRa technology. Reduce power consumption. LoRa technology is already known for its low power consumption. However, future enhancements could aim to reduce power consumption even further, making LoRa devices even more efficient and cost effective. Integration with other technologies. LoRa technology can be integrated with other technologies such as Bluetooth, Zigbee, and Wi-Fi to provide a complete IoT solution. Future enhancements could focus on improving integration capabilities to making it easier for different technologies to work together seamlessly. And coming to the conclusion, one of the key benefits of LoRa technology for smart cities is its ability to support a large number of devices over a wide area, making it an ideal choice for large scale deployments. In addition, LoRa technology is an open standard. This paper presents two applications related to it: monitoring of municipality waste collection as well as management of urban lighting. It is seen that such applications will lead to creation of so-called smart cities, where such services are provided with higher quality by municipal companies. It is good to use such devices with battery or renewable power supply. Future enhancements of LoRa technology will likely focus on improving its capabilities, long-range communication in the IoT and M2M industries.